Okay, you guys, so today is your review day, so we are going to go over our review notes. This will be the last notes before your test next time. So let's just dive right into it, okay? So in number 1, it's asking us to define all 5 exponent rules talked about in class, okay? So let's define them. I'm gonna write them out. So first one is our product rule. Okay, then we're gonna have our quotient rule. Okay, beautiful. Sorry, I was just thinking really quick. Never mind. Okay, so let's define these really quick. We'll define the rest in a second. So product rule is where we are multiplying them, meaning we have x squared multiplied by some more exponents, okay? And what happens when we are doing product rule? We are adding the exponents. Okay, 2 plus 3, meaning I have 2 x's right here, multiplying them by another 3 x's right here, or 2 plus 3, what is x going to be to the power 2? Good job, x to the 5th. Okay, so product rule, think add exponents. Okay, beautiful. Our quotient rule. Okay, this is where we have something to the power that's dividing by another thing to the power, or x to the 4th divided by x squared. Okay, you can think of this 2 ways. So we have 4 x's on top, or x to the 4th, divided by 2 x's on bottom. Okay, and what happens when we have the same thing on top and bottom? Okay, they cancel out, right? Same thing on top and bottom twice right there, so we're left with x squared on top. Okay, that's one way you can think about it, or you can just think of it top minus bottom. Okay, so we have x to the 4 minus 2. Okay, you could have thought of that way as well. Okay, that'll give you the same answer right there. Okay, so with quotient rule, you can either think subtract or cancel. Great. Okay, so let's talk about our next exponent rule. This is our 0 rule. Okay, and this is saying anything to the 0 power, meaning x to the 0, 10 to the 0, 1,475,826 to the 0 power. What do these all equal? Okay, they all equal 1. Anything, okay, write this down. Okay, anything to the 0 power is 1. Anything to the 0 power is 1. Beautiful. Okay. Our next exponent rule is our negative rule. Okay, our negative rule is, let's say we have a coefficient of 3 and it's being multiplied by x to the negative 3rd power. Okay, our negative rule says that our negative exponent only grabs what's right in front of it, and then there's always an over 1, right? And it switches it to the bottom and becomes positive. Okay, making our final answer here. What's left on top? We have just the 3, and now we have an x to the 3 on bottom. Okay, so whenever you have the negative rule, you think switch. Switch places. If it's on top, it moves to the bottom. If it's on bottom, it would have moved to the top. Okay? Awesome. our last exponent rule is our power to power rule. Okay, in our power to power rule, we have, you're almost always, pretty much always, going to have some parentheses. Okay, so you're going to have something inside the parentheses. We'll say it's x squared. Okay, and it's going to be to the power of something. We'll say x cubed. Okay, and what's really happening here is this x squared is being multiplied by itself 3 times, right? Meaning you could do 2 plus 2 is 4, plus another 2 x's would be 6 x's. Okay, or you can take that 3 on the outside, distribute it inside, and what are we doing when we distribute? What power? Multiplication, division, what are we doing? We're multiplying, so 2 times 3, and that would also give us x to the 6th. Okay, so power to a power, you're going to think distribute or multiply. Those things are the same thing. Okay, so we just defined all of our exponent rules, so let's go over to our examples. So number 2. Okay, so what exponent rule do you guys see? What are we gonna have to use? Okay, they're all being multiplied. That tells me product rule. Okay, so I see that I have an x right here. I have some y's that I need to combine, and then I have some coefficients, 4 and 3. Okay, so let's combine our y's first. We can't combine our x's, it's our only x, so let's just combine our y's. Okay, so I have y to the 4th, okay, plus another 4 y's, so y to the 4 plus 4. What is y going to be to the power of? We have y to the 8th. Great job. Okay, like I said, our x is by itself, so we don't need to combine it with anything. But what do we need to do with the 4 and the 3? They're coefficients. Okay, we just need to multiply them, right? It's telling us to 4 times 3. So what is 4 times 3? Okay, 12. Beautiful. So now let's just put all of our pieces together. Okay, we already had an x to the 4th. We didn't need to combine that with anything. So now we can put all of those pieces together. We always put our coefficient in front, so we have 12. X comes before y in the alphabet, so we'll put x first, x to the 4th, and y to the 8th. And that is our simplified answer. Okay, let's do number 3. Okay, so let's label it again. So I have my coefficients in purple, 3, 2, and 2. So I know I'm going to have to just multiply my coefficients. So I have 3 times 2 times 2. We'll figure out what that is in a second. Okay, I have my x's in pink, x, x, and another x right there. Okay, and I have my y's in green, y, y, and y. Okay, so let's do our x's next. So I have x cubed times x to the 4th times one more x. Okay, and I'm just going to add up all of these exponents, right? 3 times, or not times, excuse me, plus 4 plus 1. What's that going to give me for my x's? 3 plus 4 is 7. 7 plus 1 is 8. Okay, really quick before we do our y's, let's just figure out what our coefficients are going to multiply to. 3 times 2 is 6. 6 times 2 is 12. Nice job. Okay, last piece, let's do our y's. So I have 1y right there, another 1y, and then 2 y's. So we have y 1 plus 1 plus 2. Okay, 1 plus 1 is 2. 2 plus 2 is 4. Beautiful. So we have all 3 of our pieces. Let's just put them together for our final answer. Okay, we have 12 as our coefficient. x to the 8th, and y to the 4th. Nice job. Okay, let's go to number 4. So number 4, the exponent rule that I see, so I noticed that there's a fraction bar, right? That means it's being divided, so I know that I'm going to have to use quotient rule. Okay, so my quotient rule, that means I'm taking, let's actually rewrite this, okay? So I have my 2 on top. Okay, I have 3 m's, 1 m, and then 3 n's. Okay, and it's over 4, and then 3 n's.
Attention all Alpha seniors. Due to situations beyond our control, senior sunrise will be postponed for now. Thank you.
Sorry about that announcement. Okay, so we expanded it, right? So now we can say what cancels. Same thing on top and bottom. Okay, so I see that I only have n's on bottom, so 1 is on top and bottom, 2, and 3. Oh, all my n's cancel. Okay, so what do we have left? We have a 2 on top. Okay, we have m cubed, right? Those didn't cancel with anything. And then a 4 on bottom. Okay, I want you guys to look at just the 2 over 4. Okay, can we reduce 2 over 4? Meaning, is there a number that goes into both 2 and 4? Yep, it is. There's 2. I don't know why I said it is. It's the end of the day when I'm filming right now, guys. I just need to go home. Okay, so we have 2 divided by 2, right? 2 is the number that goes into both 2 and 4. So 2 divided by 2 is 1. Wait, do we have to write that 1? No, we don't. Okay, 4 divided by 2 is 2. And that is our simplified answer. Okay, now let's look at number 5. Okay, so this is our quotient rule again because I see a fraction bar. So I know quotient rule. Okay, so let's just do the subtract way. Okay, we could think 2 ways in quotient rule, right? Subtract or cancel. Number 4, we did the cancel way. Well, let's just think subtract. Okay, so we have our x's. What is 2 minus 1? Okay, that's 1. And is that 1 going to be left on top or bottom? Good, it's just going to be left on top. Okay, what about my y's? What is 3 minus 3? That's 0. And anything to the 0 power is what? It's 1. Okay, do we need to write x times 1? No, we don't. In fact, this x over 1 or x times 1 just simplifies to 1x. Okay, you also could have said, oh, there's the same thing on top and bottom, y cubed over y cubed. Boom, the y's cancel. There should not be any y's in my answer. Okay, beautiful. Let's go to number 6. Okay, so I see a couple of rules that I might have to use here, okay? Because that's the thing about exponent rules. You're going to get to a point where you have to use more than one, right? So I see a fraction bar, which tells me I'll probably have to use quotient rule. I see a 0 exponent, so 0 rule. And then I see 2 x's on top that might have to be combined, so that one is product rule, right? They're being multiplied. Okay, so let's combine them. Okay, so the first thing, like I said, there are 2 x's on top. Okay, let's use the same color for x's. So I have 2 x's right here. I have another 4 x's right there. Okay, so I'll rewrite this. Let's rewrite it in blue. Okay, so if I have 2 x's right here plus another 4 x's, how many x's do I have on top? We have 6 x's. Beautiful. Okay, the next rule I see is this 0 rule. What is anything to the 0 power? It's 1. And 2 times 1 is just 2, right? So we just have that 2 left on bottom. Okay, the only thing left is that 4 on top. Okay, are we simplified? No, we are not. Okay, look at 4 and 2. Look at my coefficients. Okay, is there a number, remember, that goes into both 2 and 4? Yep, it's 2, right? So what's 2 divided by 2? Right, we're going to just reduce it. That's 1. Okay, what's 4 divided by 2? That's 2. Okay, that x to the 6 stays the same. When the 1 is on bottom, do we have to write it? Nope, we do not. So this final answer is 2x to the 6th. Great job. Okay, let's skip number 7. So we're going to go ahead and skip number 7. Let's go to number 8. Okay, so there's quite a few exponent rules that I see here. So I see the fraction bar again. So probably quotient, right? Things are going to cancel or something like that. Okay, I see negatives. Okay, I see negative exponents, which means they're going to have to switch places, switch sides, right? So let's take care of that first. So find your negative exponents. So I see that I have a -1, and right, it only is attached to the m. Only attached to what's right in front of it. Okay, and then a -2 to the m. Okay, so these both move from the top to the bottom. So I'm just going to rewrite it because that looks a little messy. Okay, I'll rewrite what was left on top. Okay, so I had 2, okay, times n to the 4th, okay, and that 4. That was what was left on top. Okay, that 2m was already on bottom. Okay, and then this m squared moved to bottom, became positive, and then the m to the first power became positive. But since it's just 1, we don't have to write it. Okay, so now we can start simplifying. We can combine some things. Okay, so notice on bottom, I see that I have a bunch of m's, so I can combine these using product rule. They're all being multiplied. Okay, so how many m's do I have on bottom? If I have 1 right here, 2, and then another 1. What's 1 plus 2? It's 3. What's 3 plus 1? 4, right? We have m to the 4th on bottom. Okay, now, before I do anything else, do we see anything that's the same on top and bottom that can cancel? Yes. Okay, this 2 over 2, that's the same thing on top and bottom, so those cancel. So now the only thing left on top is this 4 and the n to the 4th. We only have one of each base, right? 1 4, 1 n, 1 m, and we are simplified. Great job, you guys. Okay, let's do number 9. Okay, number 9. So I see a few exponent rules here that we're going to have to do. Again, I see a fraction bar, which tells us we might have to use quotient rule. Okay, I see a couple a's on bottom, which I'll probably have to combine, which is product rule. And then I see a negative exponent, which is obviously negative rule. Okay, so let's start combining stuff or moving stuff. The first thing I want to do is I want to get rid of negative exponents. Okay, we need to move it. Okay, so that a to the -4th, remember it's only attached to the a, switches to the bottom. Okay, so I'm just going to rewrite it so we can see it all pretty. So on top, we had the 4 and b cubed that was left over. Okay, on bottom, we already had, so I'm just going to write what was already there, 3a to the 4th, b squared times a to the 4th. And then once this a to the 4th, or -4th, moved, it became positive, so another a to the 4th. Okay, so now we can start combining things. So on bottom, again, I see that I have a lot of a's to combine. Okay, so let's combine these a's. So I have 4 right here. I have another 4 and then another 4. So let's just take it one piece at a time. What's 4 plus 4? 8. What's 8 plus another 4? 12. So we have a to the 12th on bottom. Okay, now I see some b's that I need to combine. Okay, remember they're being divided, right? One's on top, one's on bottom. So this is quotient rule. So I have 3 on top, 2 on bottom. We could just do the subtract way, right? So what's top minus bottom? What's 3 minus 2? That's going to be 1. So 1b left on top, right? You could have also thought 3's on top, 2's on bottom, 2 are going to cancel, 1 will be left on top. Great. Last thing we need to look at are our coefficients. So we have 4 and 3. Is there any number that goes into both 4 and 3? Nope, that cannot be reduced, so that stays 4 on top, 3 on bottom, and that is our simplified answer. Beautiful. Okay, last example. Awesome. So one thing I see here is I see parentheses and then it's all to a power. Sorry, another announcement.
Teachers involved in the SAT committee, please meet in the Hop House Gallery as soon as possible.
Okay, so we know that parentheses to a power, that's power to a power rule. Okay, I also see a fraction bar, which tells me I might have to use quotient rule. And
Do you know where Mr. Satina is?
he is through that room back there. Okay, so that's kind of all I see right now. So the first thing let's do is we need to get rid of these parentheses. We need to get rid of our power to a power. Okay, so we have the 3 on the outside, and it has to distribute to every single base. Okay, every single x and y right there. Okay, so let's go ahead and let's rewrite it. Okay, so on top we have x, our first x, to the 2 times 3. What's 2 times 3? 6. Okay, our y to the 4 times 3. 12. Okay, our other x, 3 times 3. 9. Okay, and our last y, 2 times 3. 6. Beautiful. So we got rid of the parentheses. Now what's left on bottom? 2x cubed y squared. Okay, awesome. So now I see that I have x's on top and y's on top that need to be combined. So that's actually product rule, right? They're all being multiplied. So we can go ahead and combine them. So I have 6 x's right here. I have another 9 x's right there. How many x's do I have on top? 6 plus 9? 15. Good job. Okay, I have 12 y's right here. I have another 6 right there. How many y's do I have? 18. Good job. Okay, now on bottom, I have that 2x cubed and y squared. Are we simplified? No, we are not. We still have more than one x and more than one y, so we need to combine these somehow. Okay, so these are not product rule, excuse me, they're being divided, so quotient rule. Okay, so let's do our x's first. Okay, so I have 15 x's on top. Take away 3 on bottom because 3 will cancel, right? How many do I have left on top? We have 12 left on top. Okay, now let's take our y's. So I have 18 y's on top, 2 on bottom. So 18 take away 2 because 2 are going to cancel. How many y's do I have left on top? 16. Beautiful. The only thing left on bottom is that 2. I have one of each base, one x, one y, and one 2, so we are completely simplified. Awesome. Okay, those are your review notes. They should look like mine, but if you missed anything, they will be linked on Canvas for you. Okay, see you later.